Well, before we graph rational functions, we already know what vertical asymptotes are. Now let's talk about horizontal asymptotes. The horizontal line, y equals b, remember b is just a number, and remember that every horizontal line is y equals a number. That horizontal line is a horizontal asymptote of a function f, if f of x approaches b as x increases or decreases without bound. Another way of saying increasing or decreasing without bound is x goes to positive or negative infinity. When x goes positive infinity or to negative infinity, the height of the graph, f of x, the value of f of x, is approaching b. So here I've got the horizontal lines b graphed, and there are actually more than two ways that we could have an asymptote. It could look like this, where as x gets bigger, it gets closer and closer to this line. It could look like, let's say, it could be above the graph. Let's do it this way. As x goes to negative infinity, it could be decreasing like this, but getting closer and closer to it. Or we could do it the opposite directions. It could be doing this from above it, coming down as x goes to positive infinity. The graph is getting closer and closer. From above, it's getting closer and closer. Or it could be getting closer and closer from below as x goes to negative infinity. So we basically have all four of the possibilities here. If you're above the graph, you could approach it, and you could approach b as you go to negative infinity or to positive infinity. If you're below the graph of this horizontal line, the asymptote, horizontal asymptote, you could increase to it as x goes to infinity, or you could increase to that height as x goes to negative infinity. So that's what a horizontal asymptote would look like. Now, this is going to look tough, but it's really pretty simple to memorize. How do you find the horizontal asymptotes, if any, of a function? Okay, so let's look at this as our polynomial p on top and our polynomial q on the bottom. All we want to look at is to determine the horizontal asymptotes is the first two terms. Well, let me say it this way. I was going to say the first two terms. The first term of both of the polynomials, the n degree term and the m degree term. Notice these are written in the correct order, so descending order of exponents. So this is the biggest exponent on top, n. M is the biggest exponent on the bottom. So that means the degree of the numerator is n, and the degree of the denominator is m. We're going to look at those exponents. And once again, an is the leading coefficient of the first one on top, that polynomial, and b sub m is the leading coefficient of the bottom polynomial. Okay, well, when x gets really big, these terms over here become less significant as x gets really big. Because notice this x is being raised to the n power. The rest of them are being raised to exponents less than that. This one dominates it, and this one dominates this whole thing. So as x gets bigger, these hold less meaning. In fact, think about x getting bigger and bigger and bigger and bigger and bigger and bigger and going on to infinity. Well, suppose that n, this exponent, is less than m. All right, so you could have something like maybe, let me just do a real simple one, maybe 3x squared over 5x to the 5th power. and we'll ignore the rest of the stuff because we're talking about such big values of x. What do you think is going to happen? What does this number go to as x gets really big? Well, for one thing, we could simplify this. We could cancel x squared in both of them, and that would give us a 3 over 5x to the third. Sorry about these extra lines I had in there. What does this go to as x gets really, really big? The denominator's getting huge. 3 over 100, 3 over 1,000, 3 over 1,000,000, 3 over 1,000,000,000. It's going to 0. So if this exponent n is smaller than the exponent m, that means that the denominator is going to get big so much faster than the numerator does when x goes to infinity, when x gets really big. So it's going to go to 0, which means the horizontal asymptote is the x-axis, or the line, the horizontal line, y equals 0. Okay, every single time. If the top exponent, the degree of this polynomial is less than the degree of this one, the x-axis will be a horizontal asymptote. Well, now suppose they're equal to each other. N and m are equal to each other. So maybe let me do a different example. I'll do something like 4x squared over 7x squared, and we're ignoring the rest of the polynomials. These are the leading terms. Well, notice that the x squared over x squared just cancels, right? So this fraction is what the height of the function is going to, 4 over 7. So when they're equal, then the horizontal asymptote is the horizontal line y equals, what were 4 and 7? They're the coefficients, the leading coefficients. So I'm going to say a n, the leading coefficient of the numerator, over b sub m, the leading coefficient of the denominator. So in this case, it would be y equals 4 over 7 right here. Now that's only the case when the degrees are the same, they're equal. X squared over x squared, x to the 5th over x to the 5th. If n is bigger than m, that means that when x goes to infinity, the top is blowing up compared to the bottom. So it's going to continue, it's going to increase without bound, go to infinity, or maybe down to negative infinity. There is no horizontal asymptote in this case. It could just keep going up, 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 or down, 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 down. All right, that's the theory behind it. So you should memorize this, but now it's easier to do examples. That's a better way to learn this recipe. All right, let's do 3 examples. So you can assume that we're going to have one of these cases each. So you should identify which one of these 3 corresponds to this one, and then this one, and then this one. Let's take a look. Our first one is f of x is 9x squared over 3x squared plus 1. So I'll just make a note. The degree of the top is 2, the degree of the bottom is 2, right? X squared, x squared. So when they're equal, what did we learn? The horizontal asymptote is the line y equals 9 over 3. Well, that reduces. Y equals 3 is the horizontal asymptote. So as x goes towards infinity, x gets really big, the graph height, the value of the function, is approaching that value of 3. Or when it's going to negative infinity, it'll do that. One way or the other, this y equals 3, that horizontal line is a horizontal asymptote. All right, let's look at the next one. What do we have here? Remember, 9x is like 9x to the 1. So that means that our numerator, oh, did I do that wrong? Let's see. Nope, that's correct. Yeah, n is the one on top, so n is less than m in this case. N is a 1, m is a 2. So what is the horizontal asymptote? It's the line y equals 0. And just a reminder, that's the x-axis. Last one, we have n, the degree of the top, 3. The degree of the bottom is 2. We've got 3 is greater than 2, so n is greater than m. There. So no horizontal asymptote. All right, so again, you do want to memorize this, it is a bit intuitive. Hopefully it's not hard to memorize because it does make sense. Let's see what we've got. Okay, now we'll start graphing probably in the next video.